This episode of the HVAC School Podcast is made possible by our excellent, fantastic, splendiferous sponsors. Carrier and Carrier.com, Refrigeration Technologies at RefrigeTech.com. You can find Refrigeration Technologies products like Viper, Pan and Drain Spray, Nylog, Big Blue, and other products at TruTechTools.com, TruTechTools.com. Use the offer code GetSchooled for a discount. AirOasis.com/go to find out how you can use AirOasis air quality products, indoor air quality products such as the Nano and Bipolar in your business. Even the iAdapt Air, which is not designed to go with the AC equipment, it's a room air purifier, is great with ductless systems. We've been trying that out and enjoying it. So if you want to work with a company that's no nonsense, cares about the science, and will support what they make here in America, go to airoasis.com/go, why don't you? And then finally, Navac at navacglobal.com, makers of vacuum pumps, recovery machines, scales, a lot of good stuff, well made. You can find out more by going to navacglobal.com, or you can also find out more by going to TruTechTools.com and typing in NAVAC in the search box.
Sure, he was an ACHR 40 under 40 in 2017, but it's no big deal. He just has his room wallpapered with the announcement article. Brian Orr.
All right. This is the HVAC School Podcast, the podcast that is there to help you remember some things you might have forgotten along the way, as well as help you remember some things you forgot to know in the first place, like many of us technicians do. We know what we know, but often we don't learn things we don't know because we're busy doing what we do, right? And this is an opportunity for you to think about some things and learn some things that maybe you don't do a lot of. And today we're talking about something that you probably don't do a lot of, and that is water air handlers that use water as the cooling medium instead of refrigerant. And we've got Eric Melly, who's going to talk to us all about it. So here we go. All right, so we've got the great Eric Melly back in the podcast. Again, thanks, Eric, for coming by.
Second mandatory podcast.
Second mandatory paid Kalos Services podcast. Today we're talking about chilled water air handlers. So we've already talked a lot about chilled water in the past. Not really that much, but we've talked a little bit about it. We've had Jeff Nyman on the podcast a long time ago talking about chillers. You can go back and listen to that if you want to hear more about that. But this is more on the air handling side. And this is everything from residential, commercial, everything in between. You're going to see these types of applications. And really what we're using is water. And your traditionally we would think of as our evaporator coil, but now it's just a coil. It's just our cold coil that's running chilled water through, right?
Exactly. I've been informed by Brian as well that I only get 7 by the ways on this podcast. That's my limit.
Yep.
So if I forget anything, that's why. It's because I went over my by the way limit.
Mm-hmm. Let's talk first about some of the different configurations that these air handlers can come in.
Typically, you're going to see them in every configuration you're used to seeing air handlers in. You can have just regular upflow that look exactly like a residential air handler, pretty much. Pancake units to big commercial units that might be setting on the floor in a mechanical room, or they might be rooftop. Pretty much any configuration you've seen another air handler in, although these probably go a little bigger than regular direct expansion air handlers.
So as opposed to direct expansion, where we're using a refrigerant and we're changing its state, in this case, we're just flowing water through the evaporator coil. So what are some of the things that you'll notice that might be different on the inside of these things from what we're used to?
The first clue is going to be both pipes are going to be insulated in the same size. And you might see actuator on the pipe outside the unit for the water flow. You might also see a 4-pipe arrangement where that would enable them to run cooling and heating in the building at the same time. Whereas if you have a 2-pipe arrangement, you have to switch totally over from cooling to heating the whole building.
Which is common sense. I mean, obviously, if you've got a cold water supply, cold water return, hot water supply, hot water return, right? I mean, that's what a 4-way valve would be. Pretty simple.
Well, there'd be 2 different coils. You'd have 2 separate loops.
So you might run into that, but in general, especially where we are, you see more of the 2-pipe configuration. And obviously, if you're just flowing water through the coil and it's all going to be very low temperature, then that's why you have to insulate both lines.
So regarding insulation on these pipes, you have to be very, very thoroughly insulated or they will just drip a lot. So you really want to make sure you're insulated well. And if possible with your piping, when it connects to the unit, there's not going to be any insulation, but you're going to have a drain pan. You want to make sure that you're piping to the unit in such a way that if any moisture were to form inside the insulation, preferably it's going to leak out into the unit, into the drain pan and not become a problem. So if you can install your 2 or 3-way valve over the unit drain pan, that's ideal. Then you don't have to worry about insulating it as much or as good. Some of the units are going to come with additional pan that you attach to the primary pan that's going to slope into it, and they intend for you to put your valve over that and your piping connections. That way any water dripping is just going to go into the unit pan and not be a big deal.
And so the insulation is generally, 1-inch insulation on these?
People say you can get away with thinner. Typically here in Florida, I like to use 1-inch wall.
Right.
I don't have issues with that. Armaflex 1-inch wall works pretty good on smaller piping. I've seen it used on bigger piping, but they also use that closed cell foam insulation that comes split. It's usually like white on the outside, and they call it fart rock because when you cut it, it smells like a fart. That's what guys call it.
I've never done that before.
You usually see that on bigger steel piping and copper piping.
Okay, yeah, I know what you're talking about now. Yeah. It's almost like fiberglass insulation sort of on the inside of it.
No, it's like black and it's really hard, closed cell foam. It's not flexible at all. If you touch it, it's got no give to it whatsoever.
Okay.
I've seen them insulated with fiberglass type insulation, but I don't think it was a good application for it because that building always had problems with insulation sweating, and I had to replace a good bit of insulation because of that.
So what temperature do these things usually run?
Typically, I see chillers set for 44 degrees supply water temperature.
Not 45, not 43.
That's typically what I see. I mean, it would depend on your application, whether you can get away with higher or lower. And the further you get from the chiller, the more you're gonna gain a little bit.
Right.
Most likely, depending on your conditions and where the piping is run.
Right, thermal gains. Let's talk about inlet valves. What different types of inlet valves do we have?
So you're gonna have a 2-way or a 3-way valve on your water loop. Your 2-way valves are going to be on systems that are mainly on variable water flow, where the pump actually has a drive so that it can change the water flow of the system.
So a variable frequency drive.
Yes.
Okay.
And a 3-way valve is going to be more on a system where the pump runs at a constant volume so that you're diverting the water when you're not using it in the coil.
So when the system goes off, you're bypassing it basically through that 3-way valve.
Exactly. And the two main things you'll see with a 3-way valve is they go on the supply side, it's called diverting. When they go on the return side, they're called mixing. So you're going to want to look at the directions that come with yours and see where it has to be placed and make sure you're installing it correctly. Because some of them can do both, but some of them are meant to do only diverting. And there's probably some that are meant to do only mixing. But usually I see only diverting or mixing and diverting in the ones that I've used.
I can't even envision why it matters in my brain.
I've heard somewhere that mixing is the preferred setup, but that's all I really know about it.
Got it, that's on the return side.
Exactly.
There's also different types of valves. You have standard open close, and then you also have some proportional valves, you were saying?
Yes. So you'll either have a valve that's either all the way open or all the way closed, on off basically, or you'll have ones that are varying how much they open. That's usually on a bigger air handler because they usually run constant airflow. They always run the fan, so they just dial back the water as needed to match the load.
We think of variable air volume systems are kind of like that, where we vary the amount of air going through and we maintain a constant temperature, and that it changes, kind of sets in the temperature a little more stable in a space. In this case, the air is staying constant and you're varying the amount of water flow through the water coil. It's kind of similar to that, but that would be like variable water flow or something. I don't know. There's probably no name for that. I just made that up.
That's probably what it's called. Also, you'll see a lot of commercial applications where they use these with VAV boxes, and it works really well because you don't have to worry about flow. Your water is always being delivered at 44, so you can't possibly freeze up the unit. So you can run whatever fan speed you want. It doesn't matter. So they work really well with VAVs.
I imagine it does still impact latent humidity removal slightly, though, depending on the amount of air volume.
Changing the amount of air you're moving through the unit, you're changing the amount of air you're dehumidifying. So yeah.
I shouldn't have said that because now that's kind of confusing because you have higher air velocity, which is going to impact your dwell time on the coil. But then if you're dehumidifying more air, then...
So in a VAV application, you're going to reference static pressure to control the fan speed across the coil.
So you're going to have a sensor, and the sensor is going to try to maintain a fixed static pressure.
Usually 1.5 in the supply duct, the common target.
But then at the VAV box itself, at the box side, this is sort of a side note here, but you can have VAV systems in which the boxes, what am I talking about?
Exactly what we're talking about. You're going to have VAV boxes downstream, and they're going to be either opening and closing or modulating depending on what type you have. And they're they want a constant supply of 55-degree air, let's say at 1.5 static, so they know how much air is going through so they can work properly.
I just got my brain twisted there, but yes. So you could have a water coil, a chilled water coil VAV system then is what we're saying.
Yeah, it's really good for that.
Obviously, it's VAV, that's variable air volume. So you could have a variation in air volume depending on how many VAV boxes you have open or how wide open they are. And obviously, that would tend to impact the temperature across that coil. But if you have a system that's also ramping capacity in order to maintain the water temperature, then those two are going to match up really nicely.
Yeah.
So there might be a slight variation. But again, the goal in all of this is to maintain fixed evaporator temperatures, or in this case, water coil temperatures, because then that maintains dehumidification and kind of does a pretty consistent job there. And we want to maintain fairly fixed targets within our spaces. So if you set it to 75 degrees, you don't want it bouncing up and down in a wide bandwidth, because then that impacts comfort and impacts a lot of different things. So you want it to kind of maintain in that dead band. And in this application, it kind of does both pretty well.
Yep.
So I want to take this opportunity to talk to you about one of our great sponsors, and that is AirOasis. AirOasis makes indoor air quality products here in America. They source the parts as much as possible to make these indoor air quality products from America. And they do it not only because they're Americans and they're patriots, but also because they can really control the product, the quality of the product. And that's one of the main things I like about AirOasis is the products that they make, specifically the Nano and the Bipolar 2400, are products that they just last and they just work. They've done a lot of life cycle testing on them against competitors, and they've shown that it just blows away the competition. The stuff lasts. It does what it says it's supposed to do. It helps reduce odors and particulates and live gunk that lives in the air. They kind of take a no-nonsense approach to it, which I appreciate. If you listen back into the podcast, you'll hear some podcasts about the Air Nano and their Bipolar done with one of the owners, John Bennert. So I think you'll enjoy that. If you want to know more, if you want to find out more about how to integrate AirOasis into your business, then go to airoasis.com/go and fill out the quick little form there, and you'll get some information about how you can use AirOasis right there in your hometown and be the company that's using AirOasis as their indoor air quality products. I think you'll find that it's a rewarding experience. So there you go. That's what we're doing today, but now we're going to go back and talk to Eric Melly. So one thing that I wanted to mention real quick is it is tough to get readings, and I'll actually talk about that right now. Like, what kind of readings can you get off of these air handlers?
That's the challenging part a lot of times, is because you might not have the access to get the readings you need. It probably comes back to cost and to how well you tend to need to insulate the piping. But to have test ports, now you're compromising your insulation, plus you have to add the test port, plus will anybody ever be able to find it once it's buried in insulation? But there might not be pressure test ports. You might be lucky enough that there are gauges installed on the larger air handlers. There usually are temperature and pressure gauges. Now, whether you can believe the readings on them is an entirely different thing, but at least you have something to go by. But on the smaller units, you'll probably have neither, and you probably won't even have a port to add one if you needed to.
And so I was suggesting that you could use something like two Testo 605Is or the UEI Hub 2, some sort of air enthalpy probe that you could use where you could measure the enthalpy split across a coil like that. And if you knew the airflow, which again, that's another difficult thing, knowing the airflow is always a challenge. But if you did, then you could use that to calculate approximately how many BTUs you're removing, and you could compare that to specs, which could be useful. But again, it is always sort of challenging to know exactly whether or not it's perfect. But again, with a simple system like this, there's not as much that you have to check. You've got to make sure your water temperature is within range and have some indication that obviously the unit's moving the air it should move. So you've got to check blower wheels and all that kind of stuff like you typically would.
Yeah. So at the technician level, if you're there and somebody else takes care of the chillers and pumps, they might not give you access to make sure all that stuff's working properly. And they also might mislead you about the status of that equipment too. If you're like in a condo building and they're supposed to be delivering a certain amount of chilled water and maybe one of the chillers is offline, but they don't really want to tell anybody, you can get calls like that. I've been on a few like that where it's like, I don't know what you want me to do because I can't touch the chiller.
There's definitely this separation here in a lot of those types of buildings.
You'll have it with the water source units as well.
You had mentioned that you sometimes run into line voltage controls on these.
Yeah, you'll see on, I shouldn't just say older ones, but you'll see a lot of line voltage controls. I've seen 277 line voltage where the stats on the wall were actually 277 line voltage. And sometimes too, you'll have it integrated in the stat for fan speed on these because you can run whatever fan speed you want. It's not going to really ever potentially freeze the unit. So you might have a thermostat on the wall that has like 4 fan speeds right on the stat, or you might have a separate fan speed controller, or they might have just wired it to the fan speed they wanted it to be and left it there on some of the smaller units.
What about, because you mentioned that you got to be careful with replacing three-way valves with two-way valves.
Yeah, you want to make sure that you're putting the right valve in for your application, because if you didn't have a variable water flow ability, you don't want to put a bunch of two-way valves in, because now you're going to start to affect the water flow as those valves start to shut down. And
then just as a general rule with working with valves, and we talked about this previously, you got to be really careful whenever you're working with any valves. Shut-off valves, any type of valves that you're working on, you really want to be gentle, because obviously when you have a system where it's got pretty significant water flows, you break those things, you've got a major, major problem on your hands. And being prepared for it is very difficult to do. Keeping a few rags in a bucket's not going to help if you have these crazy water flows. I mean, maybe you have a little tiny leak, but not if you actually break a valve off or something.
It might be a good idea whenever you're working on a big water system like this. You definitely want to coordinate with building maintenance, have their phone numbers available in case there's an emergency. And maybe if you have enough experience, have them show you where the pumps are and the makeup water is. And if the worst happened, you have to shut off the pumps and the makeup water. Somebody's going to have to. It doesn't matter at that point. You have to shut it down. Water is going to flow, and hopefully you're not on the ground floor and have 17 stories of water above you, but hopefully you never have to be in the situation. But always be prepared in case it happens, not just stand there watching it like, oh well.
All right, so let's talk about, you said some of the coils will have air bleeds on them.
Pretty much most of the ones I've seen are going to have an air bleed somewhere on it. It might be hard to locate, it might not, but it'll look like a little threaded fitting welded on there, and there might be something you turn with a flathead screwdriver and you can start to bleed the water out. After a couple revolutions, you should be either hearing air or water come out. You don't want to back that thing all the way out.
Right.
Because you might not be able to get it back in. If it just shoots out of there and
right.
Water's coming out under pressure, you might have significant water pressure behind that.
So be careful. Yeah, don't just go crazy pulling that thing out. It's just an air bleed. Can you get any information at all from that?
You can know that the coil's not airbound, and if you have water coming out, you know you have water pressure. So really can't tell how much flow you have.
And you were mentioning that even on two-way valve systems where all the valves are two-way, you still want to have some three-way valves towards the end of the loop.
Yeah, it's nice if you can have them at the end of each branch, because if you have a building, let's say the piping comes up in the middle of the building and you have the hallways going each end, at the far end, it would be a good idea to have a three-way valve just to keep the water mixing good in case a lot of valves start shutting down.
Right, that way you don't have just stagnant.
Exactly.
Stagnation, yeah.
That we don't have huge variances in water temperature. We covered two-way valves and three-way valves, but we didn't cover was actuators.
Okay.
So your actuator is going to sit on top of the valve and going to be separate from the valve. And they usually thread on, although the bigger ones will have more complicated attachments to attach to the valve. And that's what you're going to use to control your water flow. So they'll either be on-off. We actually said the valve is going to be the on-off part, but that's not true. The actuator is what's going to determine that. So the actuator is going to determine how much water gets through your valve and whether it can be variable or just off or on. That's basically what you're looking at. If you see two wires going to it only, you know it's going to be just spring return.
So in pool heating, we do this a lot. They have three-way valves in pool heating, and it's essentially it turns a gate around the three valves, and it only shuts off one of them when you have three-way. So it's either going, in a case of a pool heater, it's either flowing through the pool heater or it's bypassing around it is one configuration, and there's others as well. I imagine it being something like that.
Yeah.
In that case, yeah.
That's pretty much it. But if you see 4 wires or more going to it, it's probably a variable valve.
Right. The proportional valves you were talking about too, right?
Or you might have a power open, power close valve too, depending how big it is. But the smaller ones, a lot of them are spring return.
Are they spring open or spring closed generally?
It would depend on where, especially if you get the multiple valve that can be mixing or diverting, and how, because they'll have like a A, B, and an AB on them. I mean, it all depends how you pipe it. You'll see piping schematics for what you want to do. So it can depend on how you orient the valve. And I'm sure you could probably get actuators that go the way you want them to go, specific to your application.
All right. Anything else we missed here?
Not that I can think of.
All right. So there we go. There's our chilled water air handler basics. Thanks, Eric.
No problem.
Thanks for listening to the podcast. Thanks for being a part of what we do here. If you haven't joined the Facebook group, that I'm going to say, hey, why don't you go do that? The Facebook group, we have a lot of good conversations over there on Facebook. If you're not into Facebook, hey, no problem. You can also interact on the YouTube channel. So you go to YouTube and then just go to youtube.com/HVACR school. You can find us there. That's another way to interact, and there's a lot of other ways. We got an app coming out soon. You can go to the website, hvacrschool.com. That's one way. A lot of different ways, and I want to hear from you. I like you. You're in my business. You're in my trade. We need people like you, people who are willing to learn and grow and all that stuff. So thanks for listening. All right, one thing that I've been experimenting with is wearing 2 different deodorants, one under each armpit. I think it's great. I think it's the way to go, but that's just my 2 cents. Thanks for listening. We will talk at you next time on the HVAC School Podcast.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.